Hello, and welcome to another episode of Boundless Body Radio. I'm your host, Casey Ruff, and today we have another amazing guest to reintroduce to you now. Dr. Vyvyane Loh is a returning guest on our show. Check out both parts of our two-part series by listening to episode 427 and episode 431 of Boundless Body Radio. Dr. Vyvyane Loh is board certified in obesity medicine and internal medicine. She is the member of the Obesity Medicine Association and the Obesity Society, She was the recipient of the Bunting Radcliffe Fellowship in Fiction in 2006, a Guggenheim Fellow in Fiction in 2008, and shortlisted for the 2005 International IMPAC Award in Literature. Her diverse skills support her commitment to celebrating the full range of our humanity in an increasingly technological and disembodied world through art and the healing sciences. Along her professional journey, she realized that most of the healthcare industry in which she was trained is, in reality, a sick care industry, and she is striving to change the paradigm of weight loss and obesity. She is also the host of the amazing VLMD Rounds Podcast, and today we'll be focusing on one of her recent episodes titled Reviewing Dayspring and Attia. You can find Dr. Vyvyane Loh on her website at www.vyvyanelohmd and on YouTube at VLDM_rounds. Vyvyane Loh, what an absolute honor it is to welcome you back to Boundless Body Radio.
I'm delighted to be back, Casey.
It's such an honor to host you. You are incredible. As soon as I saw that your podcast put out a new episode, I always look. I listen to every episode, and they can be quite technical, but they're very, very good. And I saw the title of this one, and I got about halfway through listening to it, and I was like, I got to reach out to Dr. Loh again. You did such a good job talking about this topic, which is so important. And we'll get into the details about this episode. And I just want to start by asking you why it's so important to always keep in mind first principles when it comes to science and medicine.
I think it's because a lot of times we all come up with our different ideas of how the body works. And, as we talked about before, there's not a lot of good research on, let's say, nutrition, especially nutrition science and so forth, right? And so we go back to these models, and somewhere along the way, I find that people get a little mixed up in their understanding of the models, right? Or that they don't get a full picture. They're only seeing one part of the picture, right? And as a result, we now downstream have a lot more mistakes, and it keeps us stuck in this rut where we never kind of move ahead in our knowledge based on nutrition and metabolic health, right? And so for me, it's often important to just kind of take that information in and then step back and have a bigger view of it, and to consider what it means in terms of this first principles, right? Because it can get very complex, and especially when we come to things like biochemistry and the different pathways, I find that a lot of times people spew names and enzymes and pathways, and it's a way to kind of gain credibility. But, we can look these things up, Casey, right? At just one click now we get, so there's nothing special about knowing a certain pathway. I think what's more important is understanding the implications of that pathway, understanding how this pathway fits into the bigger picture of our physiology, right? The context of the body under different circumstances, and just making sure that it adheres to first principles. Because if it defies first principles, you should be going, let me take a real good look at this, because something's not adding up. Something's not fitting, right? So my first test of seeing whether something is credible is to just go back and think about it from first principles and say, does that make sense, right? And I did quote Feynman in that episode where he says, really don't consider who is saying this. Think about what he's saying, right? And the context and so forth, and ask yourself, is this reasonable, based on first principles? You didn't quite say that, but no, the assumption is this reasonable based on first principles? And if it messes with first principles, we've got a huge problem.
Yeah, that's amazing. You made this point in your podcast as well, that when we're looking at really true scientists and researchers, their entire job is to prove themselves wrong. And you think about our human nature and how incredibly difficult that is. If I have an idea and I think something and I start to want to believe it, it's going up against all of my human nature not to just always look at the things that are supporting my claims. And I would definitely want to ignore anything that is showing that my claims are maybe not correct. And so maybe a word from you about how amazing it is to be a scientist and a researcher and to be always thinking about how am I going to prove myself wrong? It's so incredibly difficult.
I think we don't think about how proving yourself wrong adds to the entire knowledge base, right? Because there are infinite possibilities out there. And, you could just take a stab at it and hope for the best and, kind of surrender yourself to the probability gods, or you can systematically go through each possibility and prove it right or wrong, right? And every time you prove something wrong, then we add actually to our knowledge base. And we don't think of it that way. And unfortunately, I think that, this whole publication pressure also adds to that. Because now, I think people only are primed to publish things that, kind of support their hypothesis, right?
Mm-hmm.
And I think when you prove yourself wrong, you open yourself up to other possibilities that can be just as amazing or even more amazing. And oftentimes, the alternatives may be so out there that, it's mind-boggling, and we would never have even considered it if not for the fact that we proved ourselves wrong.
Yeah, so well explained. So, okay, so what we're talking about today, we'll get into the topic. This is a series of podcasts that was done several years ago. I want to say it was a 5-part series on the Dry podcast done by Dr. Peter Attia, where he hosted Dr. Thomas Dayspring. I remember listening to all of them. It was back when I was catching all of Dr. Attia's podcast episodes about all kinds of different things. And I'll even go back, it was probably a decade ago that he wrote an article called The Straight Dope on Cholesterol. And me being a personal trainer and just learning a little bit about how the body works and nutrition, this was a revelation in understanding what cholesterol was, what the subfractions were. We had just started doing very simple lipid panels. We were trying to decide what's important, what are we looking at, what's just noise, what does HDL do, all this stuff. And so I have to say, when I go back and look at my own, feeble knowledge about this topic, Dr. Attia was very influential in helping me kind of understand different things. And so you did such a good job on the conclusion of this episode to say we're not attacking anybody. You're clarifying things in your episode where you went through and you listened to some of those episodes and came back with a few, rebuttals. And we want to start this episode by saying they got a lot of things right. It's very interesting. It was very technical. They did a great job. And we're not here to try to say we're just going to poo-poo everything they did in that series. Is that correct?
Yeah. I mean, again, I don't think there's any benefit in, just kind of disparaging others and putting others down just for the sake of that, right? But, on the other hand, someone with Dr. Attia's reputation and also Dr. Dayspring's reputation, a lot hinges on, the content that they bring forth, right? People like yourself are listening and learning from them, right? And, that series that he did, I think, got a lot of attention. There were, at least on the YouTube version, many, many views. So people really wanted to know this information. So I think for me, it was when I listened to it, realizing that there were fundamental principles that had been ignored there that was, I guess, a bit worrisome for me. And the idea wasn't to attack them. It was to just kind of set the record straight, because I think that as much as we talked about cholesterol, I think we've only seen one corner of the cholesterol universe. And we're trying to infer everything about cholesterol from that one corner, right? We're just looking at, one tiny galaxy in the whole universe there. And I think it's dangerous to kind of draw these big mega conclusions based on one corner of the universe.
Yeah. Okay. Excellent. So you tell the story in your introduction in this episode, but tell us how this came about. I think somebody wanted you to take a listen to this and you had kind of put it off. We all know how absolutely slam busy you are all the time. It must have been quite the undertaking, not only to make the episode, but listen to all the content, because it is several hours long. Tell us how all of this came about.
Yeah, so I am very involved in dance, and I was at a dance class, and my friend Tom said, "Hey, have you ever heard of Peter Attia?" And I said, "Yeah, I know of him, but I have not heard his podcast or anything." As well, I was just curious because he talked a lot about cholesterol and lipoproteins, and I was listening in, and it seemed very interesting, but I wanted to know your take. And, I've talked to my friends about different aspects of nutrition and health. So he just wanted my take on that series. I went and found it and just started listening in the background. But I mean, almost from the start, I was like, what did he say? Rewind, rewind. Like, did I hear that right? And then, or sometimes I'd be like, wait, you know, rewind, rewind. I'm not sure. Did he just say that? And I did it so many times, right? And at the same time, a lot of other people came out of the woodwork and started asking me, what do you think of this series? And that's when I started to think about making it into an episode because I was just going to do it and talk to my friend. The reason I made that decision was, wow, so many people have asked, right? That means that they've all listened to it and they have questions or they just want to know should we take this seriously, right? So it's worth actually investing some time listening to the series and kind of putting forth all the bits that didn't add up for me. So
Yeah.
that's kind of how that came about.
That's great. As you were listening to it, obviously you were making notes and wanting clarifications and things. I love that you use the term fuzzy. Things were a little bit fuzzy. That didn't quite click or it wasn't quite clear enough, which you provided tons of clarification in your podcast. But as you were listening to it, what were your favorite parts? What did you like about listening to this?
Um, I don't know if there were favorite parts because I think I was trying to take in the fact that that there were so many fundamental mistakes, right, that have been put forth. And and at the same time, these were two very distinguished gentlemen who were very involved in education and so forth. And I think, the whole time trying to sort that out in my head. Okay. And we often, you know, we talk about how there's not a lot of good, credible information out there in science, but then we come to associate certain people with more credibility than others, and we give them more of our trust than others, right? And so in our heads, a lot of times we form a group of people that we inherently trust more, and then one group that maybe, we question a bit more, right? And these two have all the qualifications to put them in the high trust category. And as you mentioned earlier, they've done a lot, and obviously they've done a lot of good things and given out a lot of good information as well. But when it came to the world of cholesterol, and especially with their stated intention of raising this to the level of, let's say, a lipid fellowship, so they were really raising the stakes there, and they wanted to kind of push the academic limits of this, right? um, then when you listen to it and you realize all the basic academic principles are kind of really off, that for me, I was just always trying to come to terms with that, right? So when, for example, at one point he talked about how all cells make cholesterol and you don't have to worry about delivering cholesterol. And he talked about you would only have to worry about it if the synthesis was broken. So this, listening to that just kind of made me realize how his thinking went off track, right? Because if you're thinking, well, you don't need to bring cholesterol in unless the synthesis is broken, tells you this person has separated two processes. There is the synthetic pathway, and then bringing in cholesterol, and they're separate and they're not related, right? And you can call on each one as needed, which isn't how it works. So listening to how they phrase something, how he phrases something, how he's thinking through something was interesting to me. It wasn't just finding, oh, the inconsistencies or the inaccuracies. For me, because I am very interested in education, what interests me the most is looking at someone's thinking pattern and identifying where the thinking went off track, right? that's more useful to the person than, oh, you got this wrong, you got that wrong, right? So.
Okay, excellent. That was great. Before we deep dive into some of the criticisms, some of the things that you clarified, maybe we could talk about what cholesterol even is, why we have it, what we use it for, why it's so important that the body can take it into cells and also make it in most of the cells we have in the body. Tell us a little bit about really like high level view of like what cholesterol even is.
So, I mean, we classify cholesterol as a lipid, right? And there are many types of lipids in your body, but cholesterol is in the category of sterols, and it forms, it forms a huge component of your cell membranes, and it makes up a large part of your brain as well, right? And it also ends up being sort of the starting point for the formation of other products in your body that are important for cell growth and proliferation. So we have all our hormones, the steroid hormones, like let's say the cortisol, glucocorticoids, the mineral corticoids, the sex hormones, your progesterone, your estrogen, your testosterone. All of these use the backbone, almost the skeleton backbone of cholesterol, and they are formed as a component of that backbone, right? So the byproducts or the end products of cholesterol are also very important in life. So they did mention, and this was as good of them to talk about the steroid hormones and those end products of cholesterol. And they did mention the importance of cholesterol in cell membranes. And without cholesterol in the cell membrane, the cell just isn't viable, right? And not just the cell membrane, there are different compartments in the cell that also have membranes. And we also need cholesterol in those compartments, right? So, and then furthermore, within membranes, the addition or subtraction of more or less units of cholesterol changes the structure of those domains in the membrane. So not only is it necessary for forming a membrane, but it also controls different domains and different functions in those domains. Right. So it has many layered sort of functions there. And then one component that I felt was completely missed, but is really crucial, is the immune function of cholesterol. That people don't realize that your immune cells utilize cholesterol metabolism to turn on or off different types of inflammation. So if we're going to have a particular type of inflammation, we might be using cholesterol metabolism in a certain way so that we make, a set of inflammatory cytokines to turn on that form of inflammation. Okay? And if we had different cytokines as a result of cholesterol metabolism, then we would have a different signaling pathway that would lead to another type of inflammation. So your immune cells are actively using cholesterol and cholesterol metabolism to generate different forms of inflammation. And that has been completely ignored for a long time, not just by Attia and Dayspring, but by many people, right? And then there's a component that is super, super interesting. There is constantly this hide and seek going on in your body where your body is trying to deprive any pathogens, any invading viruses or bacteria into your body from accessing the cholesterol. We talked in my review about how expensive it is to make cholesterol. It's really energetically very expensive. And so for any microorganism that gets into your body and needs to grow, divide, and invade your cells, it's going to need cholesterol to form membranes and so forth, right? And it's going to cost them a lot of energy. And so they're constantly seeking out cholesterol and seeing if they can siphon off cholesterol from our cells. And your immune cells, at the same time, are constantly trying to shuttle away the cholesterol, hide away the cholesterol, right? So that part of cholesterol's life is sort of never discussed. That it's constantly being hidden or taken away from different cells or added to certain cellular components to sort of evade microorganisms or to elicit specific inflammatory responses against those microorganisms, right? That is a huge component of cholesterol's role. And, we don't, I never hear people talk about that.
It's so amazing to learn about this super important thing. We always, hear the saying that like if all your cholesterol left your body right now, you would die instantly, which is true. But like to think that also at the same time, if I go out and ask 100 random strangers, is cholesterol good? I would expect probably 99 and a half of them to say no, cholesterol is bad. How did we get to this place where we talk about cholesterol being this terrible thing when you just listed all these amazing things about it?
I think, again, it's the disturbing studies that we rely on, which are mainly based on correlation and association, right? The fact that you find cholesterol in plaques, right? It then seems to imply that it is causal. It doesn't imply that at all. I mean, the most you can say is that there is some kind of association or correlation, right? But there's nothing that would imply causation, as we well know. But again, I think in the general medical world and in the general public sense, the idea of association is linked to causation. And so now we perpetuate this. And unfortunately, it's perpetuated a lot within the medical world. And, again, what the medical world gets is fed to it often by pharma, right? Don't forget that our medical system is really not based on science. And this blows, it's hard for people to understand this because they're always thinking, oh, well, it's science-based. No, the medical system is not science-based. It is always based on guidelines and algorithms. I want to remind people of that. The entire medical system and the way that we practice medicine is based on guidelines and algorithms. Who makes the guidelines? Well, a lot of times pharma has a large role in making the guidelines. You'll see in the guidelines committee, lots of people from pharma in that committee, and they are guiding the guidelines, right? And the algorithms come out or feed out of the set of guidelines that were made. And now every doctor is given the algorithms and the guidelines. And then there's this inherent threat hanging over the provider, right? Oh, if you don't do X, then you'd be going against the guidelines. Okay. Now, it doesn't occur to them that the guidelines don't necessarily associate with science. So the fact that you might be going against the guidelines doesn't equate to you going against science. But it's hard. That's too complicated. It's too much, right? So because those guidelines have mainly other interests besides science, economic interests and so forth, business interests. So the furthest interest from those guidelines would be, science, right? If you think about it. So when you think about that, you can understand why we get this myth that, oh, when you think about cholesterol, it's bad. Now, it's interesting because when you talk to scientists based in the biological sciences who do hardcore science, right? And they're working on, let's say, the immune system, or they're working on certain pathways, metabolic pathways and so on. When you speak to hardcore scientists, they actually don't buy into this idea of cholesterol being bad. And they go, well, that's sort of the myth that's being spread, right? But in the medical world, it's very, very strong. It's very strong, and that this clinging to that, and this, I don't think they're understanding that they're clinging to a guideline essentially.
Yeah, it's so interesting. We just did an episode with Dr. Mark Cucuzzello, and we talked quite a bit about GLP-1 agonists, the new hit drug for weight loss and obesity, which you would be very familiar with. And you start to get the sense, like the people that have dug deep into these things have found that the companies that are making the drugs, they paid for the trials, they designed the trials, they put on the trials, they decided what data was included, what was interpreted, how it was presented. They did their own peer review, and then they paid the doctors to go out and talk about it in all these conferences. And you're like, there's no end to conflicts of interest in the industry. It's insane.
And a friend of mine who used to be in charge of these different trials, he said that the thing that people don't realize is if there are negative results from a trial, those don't get published. they choose not to publish those results. So again, we select out the things that we publish, right? So that's when people ask me, do I read like, all these? I don't have much interest because it's so contaminated that to me, it's like, well, should I read some real science or should I read fiction? Right. And, I prefer my fiction in other forms. There are much more skilled fiction that I'd rather indulge in. So, I choose to read the hard sciences if I had to. So, yeah, they hand select the positive results and promote those and publish those. But if they have a negative result, they're not going to publish that. Why would they? Why would they spend the money on publication, right? So that in itself is already troublesome. And then speaking of GLP-1, just a little kind of promo, I will be doing an episode specifically on GLP-1 that's coming up probably at the end of March. And I'm going to really dive into the deep science of GLP-1 because I think, I got to a point where I was just frustrated and fed up because a lot of times doctors, drug reps, they're like, oh, you should prescribe these GLP-1s. Great. How's it work? Incretin, it's very, very good somehow. And I'm like, no, wait, I didn't hear a pathway. Can we rewind? And basically, they're asking you to write a script for something that you don't really know how it works. Okay, well, that's interesting. When we find out how it works first, and I would be way more comfortable, right? So I had to do a deep dive myself, right? And I'm preparing for this upcoming episode. There will be a very deep dive on GLP-1. And clearly the science is there, but we've not focused on it and people don't really understand because it is more complicated than people realize. And every conference that I've gone to where they pull out the GLP-1s and they talk about how wonderful it is, every time I go, I listen and I'm waiting to hear the pathway, how it works mechanistically. Never hear it, never. And so that was really frustrating. I thought, okay, I need to do an episode on that. So just a little plug, and maybe I'll come back and talk to you about that.
Oh, I would love that. That would be absolutely amazing. I would absolutely love that. Very much looking forward to that episode. As we continue with our chat about cholesterol, I think this is important to set the stage for context as far as the things that you found troubling with this episode. But can we talk about lipoproteins and how cholesterol travels about the body? I think most people understand that fat and water don't really play together, and your blood is water based. So fat and lipids and sterols, they need to travel around in something to be able to get to where they need to go. Can you kind of give us an overview on that?
Right. So we've evolved an efficient transport system, right, in the form of these lipoproteins, which have a phospholipid layer and then is wrapped around by different proteins. And the proteins help it be more soluble in your plasma and also can interact with other enzymes and kind of facilitate different biochemical pathways and so forth. So there are many things that those proteins can do, but it helps keep those lipoproteins distinct and separate in many ways, and is involved in the function of different lipoproteins. And what we have is this packaging, which is a phospholipid layer, lipid layer there, and then, as I said, these proteins wrapped around it, and they can differ depending on the type of lipoproteins. And the cargo, which is what's contained inside the lipoproteins, would mostly be triglycerides, but other lipid structures, the fat-soluble vitamins, for example, cholesterol as well. So that would be considered the cargo that is being delivered to cells in different parts of the body, right? And one of the biggest things that Dayspring said that I disagreed with was that he felt first that phospholipids were the main cargo for the lipoproteins because according to him, phospholipids are made only in the intestines and the liver, which again is completely untrue. They're made in all nucleated mammalian cells. So if you think about first principles again, right, it doesn't make sense. So, we need the phospholipids to make cell membranes, correct? So if a cell membrane gets damaged, for some reason, gets dinged, damaged, which happens all the time, right? Or that cell needs to replicate, make another, cell, right? It's going to sit around and depend on those cells in the liver and gut to make the phospholipids and then deposit it on a lipoprotein and let the lipoprotein travel through your body to get to that cell before it can repair its membranes or before it can, proliferate. Does that make sense? I'm just sitting here going, that would be an immense backup if you think about what's going on in your body. And so just first principles, you don't even need science there. You'd be like, that's a bad business model. You would not survive, right? You just would not survive. And I was like, how is this possible, right? So his belief is that the lipoproteins are primarily there to transport phospholipids. And the reason they're not there to transport cholesterol in any form is because, according to him, all cells in your body make cholesterol, okay? With, according to him, a few rare exceptions. All right, let's just forget the exceptions for now. Now, okay, so all cells make cholesterol, so it never needs your lipoproteins to deliver any cholesterol to it. And this is just not true because, cholesterol is exquisitely controlled. The levels of cholesterol in the cell is so important that we have this very fine built-in mechanism in every cell, a nucleated cell, that allows for it to control what we call the accessible pool of cholesterol. And again, here is another critique that I have. They just kind of said cholesterol. So we think, oh, it's a free-for-all cholesterol. But the cholesterol we're talking about here, that they were talking about, is a very small pool, what we call the accessible pool, right? Because there are other pools of cholesterol that you normally cannot access. So the essential pool, that is essential for the structure of the cell membrane, your cell would die without that essential pool. But then we have this middle category of a mixed pool, right? It's called single myelin pool, generally not accessible, but under conditions of inflammation, yeah, you might actually be liberating the cholesterol there and allowing it to enter into the accessible pool, and that would increase, the levels of cholesterol available, right? And that has its own implications. Again, they never discussed that. So that's the, oops, sorry about this. I need to turn that off. So those are some of the nuances that I think they miss. But anyway, your cell has exquisite control over the levels of cholesterol inside the cell. And it's dependent on a transcription factor called SREBP2. And this is able to detect the levels of cholesterol, accessible cholesterol in the cell. And when those cholesterol levels are too high, it actually focuses on exporting cholesterol and shutting down any synthesis, right? Oh, well, we got to get rid of some extra. But when the levels are too low, it actually goes to the nucleus and it's going to turn on a set of genes. Now, it doesn't turn on specific genes just to initiate cholesterol synthesis. And it doesn't turn on genes specifically just to bring in more cholesterol. You have to think like a cell. A cell's going to say, we're low in cholesterol. We'll get some. Okay. And now the cell is thinking, well, we'll get some any way that we can. We're going to have to make some. And if we can bring some in, that's even better because it's going to cost us a lot to make some. I mentioned that it's 100 ATP equivalents and 11 molecules of oxygen to make one molecule of cholesterol. That's a lot to spend. So if you can salvage some, if you can take some from the external environment, you bet the cell is going to do that, right? Every cell, even as I said, microorganisms would love that, So it turns on a set of genes that help increase the cholesterol pool. And that's by making more and by bringing more in. And so, the fact that he couldn't distinguish that showed that he didn't really understand how that homeostatic control functioned in the cell. And I think that's vital because if you listen to what he said, it seems to make sense. And if you're not aware then you think, yeah, well, all cells need, so we don't need the lipoprotein. That's not true. That's not true at all.
Yeah, that's such a good point. That was really confusing for me. I had never heard that, or the idea that cholesterol should never be delivered from any of these different particles. Like I don't know about that. And you made such a great analogy. I love that you put this into analogy of you being a pretty decent cook. And let's say you wanted to cook your own dinner, but maybe it's been a really, really long day. What are you more likely to do?
Right. And you know, it's a lot of work to put all that cholesterol together, right? So, hey, you know what? I'm just gonna dial Uber Eats or something.
Some
Right?
nights it's a Grubhub night.
Yeah, you just want it delivered, right? And whatever is available out there, you, especially if you're a cell that's, you know, needing the cholesterol levels to go up, you know, you're not going to be picky, and in fact, it'll be a lot easier to bring in cholesterol.
Mm.
Yeah.
So it can do
So
both. They're not mutually exclusive.
no, they are not mutually exclusive. Now, he mentioned this, like when the synthesis is broken. Well, when do we deliberately break the synthesis part? When we give someone a statin. Okay, because when we give someone the statins, we're actually preventing the synthesis part, right? So now when the synthesis is broken, and most times that's through our intervention, most famously through the use of statins. Now when the synthesis is broken, right, then your body says, okay, we can't make more cholesterol, but it's going to prioritize bringing in the cholesterol, right? So we upregulate the LDL receptors, right? And so we drop the levels of the plasma cholesterol, but because we're internalizing it now, because we don't allow the cell to make some. You understand? So it's interesting that he mentioned when the synthesis is broken, you know, because we do that deliberately by giving someone a statin.
Yeah.
So, but just to say all cells make cholesterol and they can make their own cholesterol, I'm like, well, no. And so when you do drop the levels of cholesterol, but you have inhibited all cells from making cholesterol and you also drop the external pool, all right, we have a problem, Houston, right? And you know, the fact that he was unable to see that, or maybe he didn't want to see, so that's when I, you know, brought about this idea of consistency, right? You understand that, you know, when you give a statin, you're upregulating the LDL receptor and you're bringing in and dropping the plasma levels of cholesterol that way. But then, you know, you're doing that, and you know, for the whole body. It's not liver selective, right? So now these cells being affected by statins cannot make their own cholesterol, right? And also there's not much to bring in. Now we have a problem.
Mm. Even though your serum cholesterol, like you said, is reducing, but it's just because you broke one of the pathways, and now you're upregulating those intake.
Yes, and then the liver is
there.
taking a lot of the cholesterol, right? And now, you know, basically the rest of your body it's upregulating its LDL receptor as well. But you can upregulate all you want, but if there's not much supply out there, right? You can call Uber Eats and Grubhub and whatever. You can call anyone and everyone, and they're like, sorry, our supplies are low. You're still not going to get fed.
Mm. That's such a good point. What else do we know? I know this is a big part of probably. I mean, I know both their content. It's important to both of theirs, but the idea that ApoB, you know, most likely LDL cholesterol, like the target should always kind of be lower. If you're looking at ApoB, you always want to lower it. And so they're very much in favor of statins or anything that can bring down that serum level of cholesterol. What are some of the downsides, other downsides of taking a statin, excuse me, as far as like side effects?
Well, I mean, I think we know that, you know, when you're actually stopping the production of, well, you're stopping the entire pathway, because, you know, the enzyme that is involved in statin function is quite high in the cholesterol pathway. So, you know, most of the downstream parts of the cholesterol synthetic pathway is going to be blocked or stopped, right? So that means that you're also blocking off all the metabolites. And I talked about these lipid products called isoprenoids that are really important to all your cells because they modulate the function of cell membranes. And they do that by sorting proteins and telling proteins where to go in the cell membrane, and also establishing polarity in the cell membrane. So establishing what's inside and outside. Your cell needs to know what's the inside and what's the outside, and how do we position those proteins correctly. And we need the isoprenoids to help them do that, right? And if you don't have this proper sorting of proteins to the right places in the membrane, then we're going to have dysfunctional or deregulated signaling, right? And that's going to impact your cell function. So I talked about these GTPases that need to be modified by these isoprenoids so they can go to the right part of the cell membrane and function properly, right? And this happens in pancreatic cells and it affects insulin trafficking, for example, right? It actually also impacts, GLUT4, because you need some of these GTPases, for GLUT4 to go to the membrane and stuff like that. So, in essence, you're interfering with the glucose disposal aspects of insulin, right? And I think people have pointed out the increase in diabetes when people have been put on statins. And generally, the medical world has said, well, these people were going to get diabetes anyway. That's generally what I hear when you bring that up, right? And I'm like, okay, forget the anyway. Is there a mechanism? Is there a pathway that can support this? And there are a few, and this is one of the big ones, the prenylation of proteins. If you interfere with that, you basically interfere with insulin secretion and trafficking, right? And as a result, you're going to have higher insulin resistance and then predisposing someone to diabetes. Now, again, another place where those GTPases play a big role would be in mTOR, which is, famously, people associate mTOR with muscle function, right? Now, don't forget, mTOR works where? At the lysosomal surface, okay? So it's a membrane surface, right? And for it to properly locate there, we need these GTPases, we need these isoprenoids to place the proteins correctly in the membranes for it to function. And if you don't have that, then you will basically not have a functioning mTOR unit, right? And might that interfere with muscle regulation, muscle function? Right? Not saying it is the reason, but now I can see a pathway, right? Now I can see a pathway and I'm way more interested. And I would probably, double down and look into those pathways, right? Rather than just say, well, I don't know, it's just in your head. Don't worry about it. So it's kind of interesting to me what's in our head and what's not in our head, right?
Yep.
What's in our head normally, is something that fits their narrative of why you should keep using these drugs, and there are no side effects that are really kind of crucial to your functioning.
Yep. Okay. That was fantastically explained and a really good segue as far as the things that are in our head, the things that we think about. And maybe this is a good time to say, I really hope I'm not overstating the way he said it, and I'm paraphrasing, of course, but it seemed to me, again, I hope I'm remembering this right, but it seemed to me that they were saying that cholesterol is basically slamming into the arterial wall, and that's where deposits are being made. And you had to step in there and say, whoa, like, hold on. Did I get that right? Was it like a physical, like, these particles are smashing into arterial walls, and that's the problem? Am I overstating that, or is that kind of what he said?
No, I don't think you're overstating it. Because again, he talks about illegal dumping and how the LDL particles are forcing themselves into the wall, and that's leaving a lot out there that's not explained, right? But generally, the LDL particles are transcytosine. And I talk about this as a regulated process. There are different ways in which it gets brought into the cell. But we form these pockets, and there are different ways to form the pockets. There are ways where we call clathrin coated and stuff like that, caveoli. I don't want to go into the science of it. But essentially, we form these pockets and that envelop the LDL particles and then kind of bring it into the cell, okay? And generally, we can consider that transcytosis. So we're actually bringing the LDL into the cell. If you think about it, the endothelial cell is not different from other cells in your body, right? They make cholesterol, and they also bring in cholesterol. You know what I mean? Why would they? Well, all cells do that, but your endothelial cells don't do that. Why? I have not seen any reference to that. Understand? So just like other cells in your body can make cholesterol, they make cholesterol. And other cells in your body, can upregulate LDL receptors and also bring in, cholesterol in different ways. Your endothelial cells can do that. Now, a big, big glaring omission was the glycocalyx.
Yes.
Okay, so, and this is true of almost any textbook that you see. You'll see the endothelial cells in the blood, and it's almost like the lipoproteins and blood elements, the immune cells and so forth, are in direct contact with the endothelial cells. That's not true, because we have this brush border, this smooth kind of gel-like lining that we call the glycocalyx, and it acts as a permeability barrier. And, it makes what we call an exclusion zone. So it's like those bumper cars in the amusement parks, right? And you never quite hit the car because the bumper is there, right? Big bumper there. So you don't damage the car itself, right? You just bump up against each other. So we have this nice, thick, lush glycocalyx that acts as a bumper. And there's an exclusion zone, meaning that if you look at the blood, you won't see the red blood cells, for example, in contact, direct contact with endothelial cells. Why? Because they're butting against that bumper, the glycocalyx, right? And that's normal. And that allows it to kind of move smoothly through the lumen. Yeah, substances will move smoothly through the lumen. However, if you degrade or you cause damage to that part of the bumper, now you expose the inside of the bumper, which is full of negative charges, because the gel that makes up the bumper is made of substances that are highly negatively charged. And your ApoB has a lot of residues that have positive charges. And now you can see the attraction by ionic charges of ApoB to that part of the vessel wall. Now, more importantly, if you oxidize ApoB, right? And that's why, I wouldn't worry so much about LDL, but I'd worry about oxidized LDL particles, because now you've modified the LDL, right? And these oxidized ApoBs are exposing a lot more amino acid residues that have the positive charges. So they are actually more positively charged than usual and are going to be more attracted to that negative layer. Once they get in there, they get trapped, yeah, and then they get much closer to the endothelial cells or come into direct contact with the endothelial cell. Now they can get transcytosed in. Now, inside the vessel wall, we also have a layer of the proteoglycans. So you can consider another sort of glycocalyx within the vessel wall. Okay, it's not quite, but you can think of it because it's made of the same components. So now, if your LDLs have entered, right, they're going to be attracted to the negative charges on the internal layer and be trapped there. Right? And in fact, in one of the slides, I showed that if you got rid of that proteoglycan of that layer, you would have more entry because there's no barrier, there's no bumper, but there's no retention either because there's nothing in there to hold it, right? It's the ionic charges in there that are holding the ApoB in that layer. Does that make sense?
Yeah, that makes amazing sense. That was so well explained. I love that. So I guess it begs the question, what is damaging the glycocalyx and what is oxidizing LDL? And are they the same thing?
They may be. And, so these were the questions that they should have asked, right? In a lipid series that hoped to be at the level of a lipid fellowship, right? Because they completely missed the glycocalyx. So exactly that. If you go back to first principles and you realize that we have this bumper, and this bumper is very, very vital to the health of the endothelial lining, right? Then the main thing you're going to ask is, well, how do we keep that healthy and what's going to damage it? Shouldn't we know that, right? So any kind of oxidative stress, of course, high glucose, right? High levels of glucose in your bloodstream is going to increase glycation reactions and have these glycation products, end products, that are very toxic, okay? And that will damage the glycocalyx, yeah? And also, any kind of oxidative stress, right? Really, some of the most inflammatory causes of oxidative stress will be from, an enzyme called NADPH oxidase, which comes from activation of your renin-angiotensin-aldosterone system. Okay, and we don't have to go into that, but that is very potent in, increasing oxidative stress in the body and also in the vessel wall. Damages your glycocalyx, right? So also mechanical forces can damage your glycocalyx, right? Changes in mechanical forces, yeah? So there are many ways that you can damage the glycocalyx. So preserving the health of the glycocalyx is vital, as you said. Now, what's oxidizing the lipoproteins? So modified lipoproteins can be oxidized in so many ways. You can just oxidize the protein components, the ApoB. You can oxidize the phospholipids, right? So any component of the lipoprotein can be oxidized. And once you do that, you have modified that lipoprotein, right? And changed it in some way. And whether you only oxidize the ApoB part, the protein part, or only the phospholipid part, you now have, a structure that is more drawn to the wall of the blood vessel, right? And more likely to be retained in the blood vessel, right? So we have, for example, the phospholipids, it can be converted and oxidized to lysophosphatidic acid, okay? Which is, so if you think about Lp(a), it carries this enzyme called autotaxin, which converts these phospholipids, right, to lysophosphatidic acid, which is very, very inflammatory. And you know that Lp(a) is associated with higher, cardiovascular disease, right? And it may be from that we have higher oxidative stress and changes to the lipoprotein. So, any of these components can be modified. And now we also have structures in your body that are not recognized, shall we say, by your immune system. Normally it should be like, oh, that's part of us, don't worry about it, right? Now it's like, I don't know. Kind of looks like Joe, but it's got that strange toupee looking thing on his head. I don't think it's Joe, do you? Right? And then they're like, I don't know, but listen, right? If it's not Joe, then the consequences could be really bad for us, right? So let's just do this. Let's just get rid of Joe. He'll understand. If it's him, there's always another Joe we can make, right? But if it's not him, we would have saved ourselves from a possible invader, right? So your immune system's always making, these judgments here. Like, is that really Joe? I don't know. It doesn't look like, just don't ask questions, right? So because the consequences are very high if it makes the wrong choice. So it's just going to say, listen, I don't recognize him. Let's just go for it, right? So now we increase the immune reactions and we actually precipitate an inflammatory response. Now, I didn't talk about it in the review, but ultimately what you now do is, I did mention it in another episode of mine, where actually a lot of bacteria and microorganisms also have lipoproteins. And your immune system is primed. The immune cells have ways to recognize lipoproteins from bacteria. If you modify your own lipoproteins, right, there's a chance your body's saying, oh, I don't know. Could be a bacterial lipo, because it's not like ours, not one of us, right? Now, so we now set off that inflammatory response because it's decided could be a bacterial lipoprotein. And now Once we have done that, the innate immune system is going to react directly, but it's also going to take in chunks of that lipoprotein, digest it, and then present those parts to the adaptive cells, to T cells, and say, does anyone recognize this? Right? And you are going, I don't know why this is going on. You are going to have certain T cells that go, yeah, I have a receptor that recognizes that, right? So what you've done is you've created a neoantigen, a new antigen. Didn't exist before. It was part of your body, but because it was modified and now not recognized by your body, it's a neoantigen. And your immune cells are like, oh, let's go out and get it. And you actually, perpetuate this chronic inflammatory response. It's kind of an autoimmune response.
Interesting. Wow.
Yeah.
So well explained. You're such a natural teacher. It's so
thank
good.
you.
That stuff just makes so much sense when you explain it. So, okay, we did a complete just 30,000 foot flyby of even your presentation, which in your podcast, which even you say is itself a vast flyby of everything. I wonder, as far as like concluding thoughts, we live in the world where, people are still talking about cholesterol. Statins are the number one prescribed drug on the planet right now. And we've got this subset of people that are presenting a new phenotype called a lean mass hyperresponder, where they start eating a low carbohydrate diet, their triglycerides drop really low, their HDL cholesterol goes really high, but for whatever reason, their LDL cholesterol also skyrockets. And you see numbers that can be quite scary, 150, 200, 300, 500, like you see it all the time. And people are asking questions, we're starting to study it. And the thing that I find interesting, at least about that world, is I'm seeing people calling their shots. They understand the mechanisms, that they're thinking ideas like, okay, this is my cholesterol's in the 500s. Somebody like Dr. Nick Norwitz can say, I'm proposing that I'm going to eat 12 Oreos a day for 6 months or 6 weeks, and I'm going to get my cholesterol down to 130. And he does. And he's just calling it shots, which I think is wonderful. But anyway, there's this hyper focus on cholesterol. It seems like now more so than ever. What practical tips would you want to leave with most people about their life and lifestyle from all the research you've done and from this podcast that you did?
I think, again, the biggest takeaway is be very careful about jumping to conclusions based on one pocket of knowledge that you have, right? And understand that at any point in time, we have multiple reactions happening in your body. So, we're seeing a net effect of what's going on in the body. And you might want certain effects in one tissue or one organ system, let's say in the brain, and you might want a different effect in other parts of your body. So I get very cautious about making broad recommendations. I think the big one is just definitely get rid of ultra processed junk. There's just never any reason to do junk. There's never any reason really to do, sugar in any form. I just don't think there's any reason for that, right? And then in terms of, vegetables, some people prefer carnivore, some people don't. I think that's going to be something that you titrate with the patient or to your own body if you're doing this, on your own. And personally, I find that that's true for myself as well. So we're always talking about personalized nutrition, and yet we want these broad categories to throw on someone and say, oh, you should all do this, you should all do that. And within a category of carnivore and within a category of low carb, there are variations that will work for some people better and some people not. Some people might be carnivore, but just have spinach on top of it and just perfect. It just somehow regulates everything, right? They maybe had bowel issues, but you just add that touch of spinach and everything's fine. Okay, so if it's working for Jim that way, I think Jim should stay that way. Do you know what I mean? And some people might find that they're better off if they don't add any of the veggies. I don't know. I can't claim to know everything. And honestly, we're going to just have to go on an individual basis and understand that. And then you have the broad signs to back you up on making sure that you don't get into dangerous category, right? When it comes to nuances like that, I think that's where we have opportunity to work with individuals and personalize things a bit more.
Yeah, that is absolutely wonderful. What a clinic this was. This was so good. I so appreciate the time that we've got to spend together. Our other 2 episodes were awesome. I listened to those quite often, honestly. I love going back and hearing those. And this has been wonderful. You did such a good job on that podcast episode.
Thank
Like,
you.
seriously, to decide which parts you were going to focus on, to explain it, to use the science. You even went as far as to say, I'm only going to look up studies that pretty much go to the day of them releasing it, so we're current on information. And if you deviated from that, you let the listener know. I thought you did an excellent job in that episode. I would recommend anybody go and check it out. We'll definitely link
Thank
it
you.
in the show notes. I hope it reaches people far and wide, because if nothing else, if the topic of cholesterol doesn't interest you, most of us are interested in some kind of science. And again, I would say very strongly that even if you don't care about cholesterol, you're going to learn something really valuable about how we learn information, collect information, and where we should be getting our information from, like you said. So grateful for you and your hard work. I don't know how you had the time to do all of that, but you somehow find time to do these major projects that are just absolutely fascinating. So Dr. Vyvyane Loh, where would you like people to go to find you and connect with you and your work?
They can go to my website, vyvyanelohmd.com. That's VYVYANELOHMD.com. And of course, just look up the podcast, VLMD Rounds, 2 separate words, on the usual podcast platforms. But especially for the Dayspring one, I recommend the YouTube, because I do put up the slides there and you can reference the transcript too. It's just easier. It's a 2-hour episode. I think it's just easier to follow along on YouTube.
Yeah, I listened, and I definitely will be going back to watch it, because some of the concepts you talk about can be a little hard to conceptualize, and the slides should be very, very valuable. So I can't wait to go check that out.
Even the lipid rafts, I put up a diagram and so forth, right? And I just want to hint, and someone has already requested a future episode, but we were talking about ApoB and, should we be focused on that? But I did talk a lot about red blood cells, right? And how much cholesterol they actually carry. And, I'm going to be doing a future episode on red blood cells and macrophages and how they play into, atherosclerosis.
Excellent. I love your podcast. I can't wait for that. That's going to be awesome. And anybody can look it up and find so many other episodes you've already done on so many different topics. It's a wonderful resource, and we're just so grateful for people like you that are doing the really good work, very thoughtful work, and work that is not biased. You're not, selling prescriptions. You're not selling procedures or anything like that. You're just trying to get good scientific information out there. So really appreciate you, Dr. Loh. Thank you so very much for all of your hard work, and thank you for taking time to be on our show today. We really appreciate you.
You're so welcome. It was fun to be here as usual, Casey.
So fun to host you. You're the best. And this has been another episode of Boundless Body Radio.